I can use circumference to find the distance and rotations of a wheel. I can use the radius and diameter to solve real-world problems. So this is the second part of our circumference lesson. So I broke it up into a lesson 2, and then this is obviously lesson 3. So let's take a look at the first one. So it says radius, circumference, or diameter. So you need to drag and drop these into the right place. So they're talking about from the center to the edge of a DVD. So that would be our radius. The length of the rim around a glass. So if I'm going around anything, it's the circumference. Breaking a cookie in half creates a straight edge. So that would be the diameter. The distance across the sink drain, that again would be the diameter. A fence around a circular pool. So if I'm going around anything, it's the circumference. The distance from the tip of a slice of pizza to the crust. So imagine you've got your triangle wedge of pizza. So that would be the radius. The tires on a mining truck are 14 feet tall. So that would be from the bottom to the top. So that would be the diameter. The length of a minute hand on a clock. So a clock is connected from the center and goes out. So that would be the radius. All right, so let's talk about rotations. So we're talking about wheel rotations and how they move. So when I'm talking about my circumference formulas, I have 2. I can use pi times diameter or 2 times pi times the radius. So it says the diameter is 27 inches. So I'm automatically going to choose this one. If the wheel makes 15 complete rotations, how far does the bike travel? So C equals pi times the diameter. C equals 3.14 times 27. So then in my handy dandy calculator, I'm going to multiply 3.14 times 27. So C equals 84.78 inches. So that would be one rotation. So that's the whole distance around the wheel. So then if I'm going to go 15 complete rotations, so I'm going to go 1, 2, 3, 4, and I'm going to go all the way to 15, I'm going to take 84.78 and I'm going to multiply that times 15. And I get 1,271.7 inches. Now remember, it's a distance, so it's just inches. The wheel on Kieran's bike are 64 inches in circumference, so they're giving us that information. And how many times do the wheels rotate if Kieran rides 300 yards? So they're giving us the circumference as 64, and they're giving us the total amount that he traveled. But they gave it to us in yards, so we have to figure out how many inches are in 1 yard. Well, I know there are 36 inches in 1 yard. So that means 300 yards would be 36 times 300. So the total amount is actually 10,800. So then I'm going to split the total into 64-inch pieces. So 10,800 divided by 64, I get 168.75. So that would be 168 3/4 rotations. So 168 3/4 rotations. All right, so now we're on a carousel, and we're at the National Mall, which is in Washington, D.C. There are 4 rings of horses, which I did below, and it says Kieran is riding on the inner ring, so Kieran's in the orange ring, and the radius is 9 feet. Then it says Mai is riding on the outer ring, which is 8 feet further. So 9 plus 8 is 17. Okay, because it's 8 feet further. So in one rotation, how far does Kieran go? So remember, we're using C equals 2 pi r because they gave us the radius. So C equals 2 times 3.14 times the radius, in Kieran's case, is 9. 2 times 3.14 times 9. The circumference is 56.52, and it would be feet. How far does Mai go? Okay, so I'm looking at Mai, and she went 17, so C equals 2 pi r again. C equals 2 times 3.14 times 17. So 2 times 3.14 times 17. And I get the circumference for her is 106.76 feet. So in one rotation, how much farther does Mai travel than Kieran? So how much farther tells me to subtract? So 106.76 minus 56.52. I get 50.24 feet. So 50 feet. So that's like, what, 8 6-foot tall people? A little more than 8 6-foot tall people laying end to end. That's a lot. All right, so now we're running around a track. So it says that the field inside a track is made up of a rectangle that is 84.39 meters long and 73 meters wide. Okay, so together with a half circle at each end. So what is the distance around the inside of the track? Explain or show your reasoning. Well, I know I've got 2 circles, and the inside is this inner ring right here. So I've got this circle here, so I'm going with my diameter is 73, so it's going to be C equals pi d. Now I don't have the, I'm just putting the 2 circles together at the beginning. So they're the 2 half circles to make a whole circle. So C equals 3.14 times 73. So in my calculator, 3.14 times 73 gives me a circumference of 229.22, and it would be meters. Now that's not including this part and this part, so I have to add those on. So 279.22 plus 84.39 plus 84.39 I get a total of 398 meters. So then it says the track is 9.76 meters wide all the way around. What is the distance on the outside of the track? Okay, so if you've ever noticed, racers try and stay on the most inner side because it's the shortest distance. So let's see how much that really adds. So I'm adding 9.76 on each side. So 73 plus 9.76 plus 9.76. So now my diameter, I'm going to switch colors. So now my diameter is actually 92.52. So I'm going to multiply that by 3.14, and I figure out that the circumference of just the two half circles together is 290.5128 meters. Now I still have to add on those lengths. So I have 290.5128, and I'm going to add 84.39. Now this didn't increase because it's a straight line, so it doesn't matter where it is in the thing. It doesn't matter when you're running a straight distance if you're on the inside or the outside. So 459.2928 meters. So it says, what is the distance? So it's almost, well, it definitely is more than 60 meters longer to run around the outside. And when you're racing, it makes a big difference. All right, so here's your cool down. I need you to go ahead and do that on Canvas. And then if you need help, there's extra practice on Khan Academy, and you can always email a study buddy or set up a link on Calendly to do this with me one-on-one, and I'll be glad to walk you through step by step.